Okay, today's another good example of the idea that last time we discussed the idea of how to find a limit, and the discussion and your homework was all about how do you find a limit if the graph, if the function's information is given to you as a picture, a graph. So the inputs and outputs of the function are depicted graphically. How do you find a limit? And then in the homework, and also last time in class, you did a little bit of work on, well, what happens if it's a piecewise function? How do you find a limit if it's a piecewise function? And what I was hoping is you would understand that the concept doesn't change at all. It's just a different way of viewing the inputs and outputs. Today, similar. Today's practice, discussion, homework is all about, I don't quite want to do that, hold on a second. It's all about, let's get rid of this one. How do we find a limit if the function is given as a simple formula? So it's not given as a graph, it's not given as a piecewise function, it's just a single formula that describes how to compute the outputs. How do we handle that situation? So it's something like this, where it says find the, and don't write these down yet, just kind of look at them. So it says find the limit for this particular function, or for this particular function, or this particular function. So there's no graph, it's not piecewise. You know, what's different about solving this kind of a problem? The first thing I do need you to memorize is the following idea. So don't write this down yet, just let me explain the idea, then you can put in your notes whatever you feel like would be necessary to make sure you don't forget it. We're going to work on several problems where x is approaching infinity. This idea only applies for when x is approaching infinity. So if x is approaching 0 or x is approaching -2, this does not apply. If x is approaching infinity, that doesn't mean x is going to become a number. That means x is allowed to grow forever. We're stuck with that idea again of what do we really mean by forever. It means just keep making the number bigger and bigger. It would also apply if x were headed in the negative direction. Because one way to think of a negative number is it's very large as well. It's just negative. So if x is becoming very, 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 very large, either positive or negative, you can use the following fact to help you solve the problem. The types of functions that are likely to have you analyze will either be exponential, power, natural log, sine or cosine, or some combination of those. The thing to memorize is that if x grows forever, exponential functions grow the very fastest. Power functions grow second fastest, followed by ln, and then sine and cosine don't grow at all. They're periodic, so their value is like 1, 0, -1, half, 1, 0, they just alternate between positive and -1. Questions? So you do have to have this hierarchy memorized. That as x goes to infinity, exponential grows the fastest, then power, then ln, and these are just periodic. And then over here I've just written kind of random examples of things I've seen on the AP test of different types of ln, power, and exponential functions. So these are not specifics, they're just random examples of what you might see. And so again, just put whatever's necessary in your notes to make sure that you're memorizing that as x grows to infinity, this is how they grow. Fastest, middle, slowest grow. Not yet, so I don't have anything, you know. Caitlin? Never mind. All right. I'm watching everybody's pencil, make sure we don't go too fast. This, I set up the calculator to just kind of give a quick demo of this idea. So what I did on the calculator is I typed in a logarithmic function and then put inside the ln function a power function to the 10th power to give you the idea that, well, this would grow quite quickly, the ln of this will not, by comparison. This power function, I made the exponent very small on purpose to kind of, again, emphasize the idea that even with a very small exponent, 1.1, this one's still going to grow a lot faster than this one. And then similarly here, the exponential function, I made the exponent 0.01x. So even with a small exponent, this will still grow the fastest. So here's the table enlarged to make it easier to see. Here's your ln function growing with different values of x. The power function, this is the exponential. So at an x value of only 10,000, 10,000 is not even close to how large x can become. The exponential is already 2.7 with 43 zeros. So it grows very fast. Questions? Awesome. Okay, so we have that memorized. The next thing we need is a problem to just kind of start the discussion. So we're going to start with this one right here. So you can put this in your notes. Okay. So again, don't lose track of, I will often say in class, don't go on autopilot. Don't get in a mode where you're like, oh, here's my homework. 20 problems of the same thing. I just sit in front of the TV and watch a show and just kind of do the same thing over and over and over again. AP Calculus is not like that. The AP test forces you to always be thinking. You cannot be on autopilot. So when you read this, make sure you know what you're reading. It says the limit as n approaches infinity for this function. So what that means is they want you to figure out if the input grows forever, what's going to happen to the output? That's all they're really asking. To solve this limit problem, I have a couple of thoughts that I found to be extremely helpful. The first thing is this. If x is approaching infinity or negative infinity, although I've actually never seen an AP question that did this. So most of the time it's this, or it's always been this. The first thing I'm going to look for is, can I compare terms that are adding? And a warning, don't try to compare terms that are multiplying. Sorry, factors that multiply. You can only compare terms that add. So this is my first thought. If x is approaching infinity, I'm looking to compare. So I look over here, and I say, okay, wait a minute. In the numerator, there's a 4 multiplied by n squared. So I can't compare those, I just move on. But in the denominator, I have n squared added to 10,000n. Those are two terms being added. I can compare them. And this is the comparison I make. If n is allowed to grow forever, the n squared term, because the exponent is 2 and the exponent here is 1, will grow so much faster than this that when n is very large, you won't really be able to even notice that you're adding anything to this term. It's like saying, when n gets really big, this becomes the mass of the Earth. And by comparison, this is like the mass of an ant. Like seriously, the comparison is that different. If you put an extra ant on the Earth, no one is going to notice that you've added something to the mass of the Earth. It's not enough to even matter. So what you can do is say, rather than solve this limit problem, let's solve an easier limit problem. Let's solve this one. It's really important that you write what I'm writing. Half of the points on the AP test come from the written section. And if you don't learn to write correctly, you will lose points for no good reason, just because you didn't write what they expected you to write. So you must have the equal sign, because you have to declare to the grader that you understand that this limit problem is equivalent to this limit problem. Question? Awesome. Next thing. Now that we've got a simpler limit problem, we can do this step. We can look to factor. It's already factored. I'm just going to list the factors separately. So this becomes the limit as n approaches infinity of simply 4 divided by 1 multiplied by n squared divided by n squared. Questions? Okay. The problem hasn't changed. All that's changed is, because of the fact that n is approaching infinity, and because of my knowledge of how power functions work, I've been able to take a complicated limit problem and create an equivalent, simpler limit problem. So this one's easier to wrap my head around, because I can say, okay, if n gets really, 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 really big, this will become some large value. So will this. And they'll be exactly the same large value. So if I take this and divide it by the same thing, this is just 1. And 1 times 4 is 4. So it doesn't matter how big n becomes, it appears the output's going to get really close to 4. And I'm done. That's it. I figured out that if the input grows forever, the output will get close to 4. Question. And that's what it means to solve a limit. So.
You have to put an equal sign or just, oh, you did it.
Yeah, sorry, my hand is in the way. Thank you, Maya. Okay, cool. One more thing I want you to write on your paper is I want you to write below this horizontal asymptote at y equal 4. And the reason I'm having you write that is I have found through 11 years of teaching calculus that students really, really struggle to remember that finding the limit as n approaches infinity is equivalent to finding the function's horizontal asymptote. They're the same thing. And the AP test writers like to put a question on the test pretty much every year that checks to see if you know that. So what they'll do is there'll be a limit question, and everyone will get that one right. And then 5 questions later, it will say something like, where is the horizontal asymptote for some other function? And people just stare at it like, I didn't even know what to do. Like, you forgot. Finding the limit as x approaches infinity is the same thing as finding the horizontal asymptote. So, question? Solid. So now what I want you to do is see if you can solve this one on your own. And I'll just walk the room and you stop me if you have a question. Go. So use the exact same principles, exact same concepts. Make sure you show your work in a similar fashion. It really is important that you learn to write correctly to get those points on the written section of the test. So. If any question comes to mind as I'm walking by, just stop me. So. Questions from anyone about anything? Oh, please.
So can you just disregard the -2n squared 2 because that won't affect it?
Outstanding question. 2 points for Rachel. Same logic, actually. This is n cubed. We're comparing terms that add, so I think of it as plus negative 2n squared, and then plus 1n to the 0. And so when I have 3 power functions being added, if n is approaching infinity, I really just need to think of the highest power.
Okay.
So like this added to this, the 1 won't make any difference. When these add, they'll both grow, but this grows so much faster than this that it becomes negligible.
Okay, so even though it's a power, you can just still disregard it?
It's all about the comparison.
Okay.
It's all about the comparison. For example, yeah, I can't say any better. It's
Yeah,
just that,
makes sense.
yeah, they both grow. It's just that eventually one is so much bigger than the other that it doesn't really contribute much to the overall value of the entire fraction.
Okay.
That's a good question. Anybody else? Oh, please.
Is it just using like terms? Or is that not right?
Not really like terms. Like terms would be something like 2x and 3x are like terms.
Yeah, but
So
like
they add. Go
it's
ahead.
the same power.
Similar idea, it's not exactly the same.
Okay.
So what I'm doing is saying, okay, here's a power function. As n gets large, this will get large. This is plus negative 5n. So as n gets large, this will become very large negative. So you'll be taking a large value and then taking a little bit of it away. But the amount that gets taken away is so much smaller than the overall amount that it's negligible. Like it doesn't really have much of an impact on the final value. Something to note here too for Allison. Look, the output value never becomes 3. It just gets close to 3. Because this does make a difference. And as Rachel was saying, these two do make some difference. They just don't make very much of a difference. So I don't know exactly what we're going to get. Maybe it's 2.99999999999999154. I don't know. But that's really close to 3. And limit means when the input is close to infinity or when the input grows forever, what happens to the output? It gets close to 3. I don't know if that helped at all, Allison. Okay. Anybody else? Okay, next one. Keep rolling. Trying to impress upon you the need to make sure you're thinking as you solve problems, not just working on autopilot. Here's a classic example of what happened on the AP test years ago. I found several problems like this. Kind of in 1983 there was a problem like this. 1985 there was a problem like this. And so they kind of developed this little pattern of getting everyone to think that they're going to give you problems like this. And then what they did one year is they put in a problem like, hold on a minute. There we go. This. So write this one down. But again, the concepts don't change. The method, the logic is exactly the same. You just have to apply that logic in a slightly different way. So solve this problem. Make sure you show your work. It really is, you get graded for your work. Make sure you show the equal sign. If you're uncertain if you're writing correctly, just ask me, I'll check it for you. I've seen people solve this problem 2 different ways. The method I'm using, I prefer, because if you decide to multiply it out first, which is, there's nothing wrong with that, except that if they get clever and they create a problem where there are 3 terms that require multiplying, the multiplying method becomes very much more difficult. So I prefer to do this. Anyone have questions how I got from here to here? So I just compared terms that are adding again. It said, hey, if x is going to grow forever, 2x compared to -1, -1 will not make a significant contribution. 3 plus -x, the 3 won't make a significant contribution. So that gets me to here. Now I can factor. Well, it's already factored, but I can list out the factors in a slightly different order. And I strongly recommend that you remember by writing that when x is approaching infinity, we're finding a horizontal asymptote. So this doesn't show up in the answers or anything, but I would write that. Please, Mikhail.
I know you hate the word cancel, but didn't you just like essentially cancel out the -1s and the 3s?
3 points for remembering that I don't like the word cancel. Outstanding. Which one did you say it again? Sorry, I got distracted by cancel.
How you basically just like canceled out the -1s and the +3s.
Like here.
Mm-hmm.
Oh, awesome comment. All eyes on the board. Mikhail gets 5 points for this. Remember, wrong is as good as right, as long as we know why. It really is. It's very common for people to think you can cancel these, but you can't. Like, don't ever think that these divide out. They don't. The only time you're allowed to divide is if you have factors listed as separate factors. So because this is now listed as factor multiplied by factor, I can create a factor that is definitely equal to 1. But I can't do the same here. Good question. So I really didn't do that. I really made a comparison and said, hey, this is going to dominate over this.
Okay.
Good comment. Yeah, these did not cancel out at all. Good question. Anybody else? Please.
Okay, so when it asks for the horizontal asymptote, do you want us like writing the limit x, or just like write out just the math?
Gotcha. I've never seen them ask for a horizontal asymptote on the written portion of the AP test. So it'll be in the multiple choice section where you don't really have to show any word. So if you want to take shortcuts, it's okay. But you really are finding the limit. Important. Allison.
How do you know like which one, did you say dominates? Like, how do you know which one you're going to use?
So I only compare things that add. That's the first thing.
Yeah.
So I don't ever compare like a 2 multiplied by an x.
Mm-hmm.
Or I don't compare this factor multiplied by this one. So I look for terms that are adding. So I'm going to compare this to -1. Because those two are added.
Yeah.
Good so far?
Mm-hmm.
Awesome. So if x is allowed to grow forever, and these two keep adding together, eventually this is going to be like 2 million plus -1. And then it'll be like 2 trillion plus -1, and 2 quadrillion plus -1. So the larger x gets, the less important this becomes.
Mm-hmm.
That's what I'm comparing.
Okay.
And so I can identify that because x is allowed to grow forever, and because I'm not trying to find the exact value of the output, I'm trying to find what the output gets close to, I can neglect the smaller value. Does that help?
Yeah.
2 points. Anybody else, please?
Okay, so I think it kind of makes sense to me that like when you like before you multiply it, you already know that like multiplying the -1 over the 3 is only going to give you -3, and that's not going to do anything for your answer. So I don't know, that kind of.
Well said. 2 points. You're always welcome to do that in my class. Like that's normal. Like you can't think, okay, I'm not sure if I have a question, but I just want to make sure this is clear. Yeah, just raise your hand and talk about it. The whole point of the discussion is to just keep talking Keep talking, keep talking, keep talking until you really can feel that it makes sense. That's the way you succeed in this class. So, please.
Question. So you're saying x can grow or whatever, so that you can have like any answer you want. But if it is, say, x grows till 0, does your answer have to be less than 0, or it won't be a valid answer?
If x is approaching 0, the method I'm using changes completely.
Okay.
So we'd have to think of it differently. In fact, we'll do that in just a second. It's a really good question. So, is that okay?
Yeah.
Perfect. 2 points for Rachel. What else? Please. Oh.
This is just like a small like thing, but when you write it out, do you always go down?
Oh, outstanding. All eyes on me. There's no law that says you have to go down, but I can promise you, you will make far fewer mistakes if you do. When you write across, somehow the way our eyes work with our brain, you can't track it as well. When you go down, you can track errors more quickly. And so I really will push you to go down. I'm not good at forcing people. I'm kind of a believer in agency. But it really does cause problems if you write across the page. And at some point, I may start giving extra credit if you do it the way I want to, because it makes me feel good. Good question. Please.
So let's say like you have like 5x to the 4th on top, but you don't have an x to the 4th on the bottom. What do you do?
Outstanding. Have an example of that. So I need to remember 2 things. I want to do this one to 0. That was asked a second ago by Rachel. Then Trey's asking for one that's more like this one. Hold on a second. Lots of examples. One moment. Oh, I remember. I'll just make it up. It's close enough. So let's go. Here. So write this one on your paper, please. Write the limit as x approaches infinity. I'll just make something up. It doesn't match what you're thinking, just tell me.
Yeah.
3x to the 5th plus 2x, all divided by 5, subtract x to the 4th. So my first thought is, because x is approaching infinity, I can make comparisons between terms that are adding. Make sure you show the equal sign. So this becomes 3x to the 5th divided by negative x to the 4th. Questions to that? Discussion's really good. You guys are very good at it. So just talk if anything bothers you. Cool. I can rewrite this as factors separated out. So now I've got 3 over 1, x to the, put a negative there. It doesn't really matter where I put the negative. Like that. Is that what you meant? You'll see me do this all year long. And I found over and over again after 11 years that as soon as I write out the factors separately, no one gets mixed up. Everyone's like, oh, it makes sense now. So any questions about that?
So what would the answer be? Would it just be negative 3x? Or?
So what's going to happen now is when x gets, oh, help me, Danny. When x gets really, 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 really large, well, this is large value divided by same large value, so that's exactly equal to 1. That's why I don't like the word cancel. It doesn't cancel, it just divides to become 1. This is just negative 3. But this just keeps growing and growing and growing and growing and growing. So as x gets bigger, this whole thing just keeps growing to a negative number. So the answer is just negative infinity. As the input gets bigger and bigger and bigger, the output gets more and more negative. So the graph would just be heading down. Is that your question, Trey?
Yeah.
2 points. Please, why?
Would it be approaching infinity or negative infinity? Negative infinity is if you cancel out all the stuff and there's still an x left over in the last one.
The previous one you're saying?
No, so with this one,
So you're going-
cancels out everything except for an x on the very bottom. Is that why it goes to infinity?
So these divide to make 1, the constant just stays where it is.
Yeah.
So this just gets, million, trillion, billion times 3.
So is that why it's?
Does that make sense? 2 points? Please.
Where'd the horizontal asymptote be?
Outstanding. 3 points. I was racking them up. No, really, it's spot on. It's the perfect question. This one, hey, this function does not have a horizontal asymptote. Because as x gets bigger, the y value doesn't level off. It just keeps getting more negative. So no horizontal asymptote. Perfect. 3 for Allison. Perfect. Really, this will help you immensely. It's been a real problem in past years. Just remember that. It's important. Yeah. Awesome. Let's do Rachel's question now. So Rachel said, what happens if we have this problem, but instead of having x approach infinity, it's x approaching 0? So I'll rewrite it just to be clear. So exact same problem, but x is approaching 0 now instead. Get that written down. Okay, if x is approaching 0, go back to my little list of how I think about these problems. My first thought is x is not approaching infinity. So I'm not going to do a comparison. I'm going to look to factor. However, in this problem, it's already factored. So once it's already factored, if x is approaching 0, you can do a comparison still. Here's the comparison. I guess it's not really a comparison. It's more just kind of a logical sequence of thoughts. X is going to be close to 0. Not equal to 0, but close. So right here, 2 times close to 0, and then add a -1. Well, I don't know what you get exactly, but I know what you pretty much get. Say out loud what you pretty much get if you take 2 times close to 0 and add -1. What do you pretty much get? -1. What are you pretty much going to get here? Here. Here. So really, when the input's getting really close to 0, the output's going to get really close to -1 times 3 divided by -1 times, that's interesting, I didn't plan that. So the output's going to get really close to 1. So when the input value is close to 0, the output's close to 1. That's what it means to solve a limit problem. No horizontal asymptote, well, okay, this function does have a horizontal asymptote, but we're not finding it because we're doing x approaching 0. It's when x approaches infinity that you're finding the horizontal asymptote. X approaching 0, you're not finding the horizontal asymptote. But I do want you to do, oh please, Tristan.
So would you be doing something similar if it was like approaching another number that's not 0?
Perfect. So x approaching infinity is kind of its own special case. X approaching 0, kind of a little bit easier as well. It's approaching a number. We'll do an example in a second. Pretty much the same logic as this. Pretty similar. 2 points. Is that what you meant?
Yeah.
I do want you to add something to your notes here. I want you to write down f of 0. This is important. This will show up in AP questions in the future. And I want you to raise your hand if you happen to know what I'm supposed to write here. So when we solved the limit, we didn't find f of 0. We didn't find the output when the input is 0. We found the output when the input is almost 0. So what's the output when the input is exactly 0? Raise your hand if you know. What's the output when the input is exactly 0? This is important. Like, this isn't in the homework, but you need to be writing it down so you don't lose track of it. When the input is exactly 0, you can do it two ways. You can just come up here and plug in exactly 0 and see what happens. I guess that's pretty much as good as any. So hands up, what happens here? Hands up, what happens here? You plug in exactly 0. Kes, what do you get?
1.
So Kes very hesitantly says 1, but she's right, 3 points. Show me your hands if you had it. 3 points as well. So this function is continuous at x equals 0. Because the two-sided limit, this is the two-sided limit because we are mentally considering that x could be a little less than 0 or a little more than 0. Turned out to be 1. The value of the function also turned out to be 1. So at x equals 0, the function is continuous. That's in the little notes I gave you on the quiz that you need to have memorized. Right here. Function is continuous if the two-sided limit is the same as the value of the function at that same point. So that you need to have memorized. Questions? Cool. Let's do another one. Have I? Oh yeah, there you're good.
Can you just say that one more time? The function is continuous.
So function is continuous at a point, and the point we just checked was x equals 0. Makes sense? If the limit, the two-sided limit, two-sided means we've considered both, left hand and right hand. That's the overall. So the two-sided limit's value turned out to be 1, and f of 0 also turned out to be 1. Hence, the function is continuous at that point. Good question. Two more for Rachel. Solid. Let's catch up in the notes. Momentary pause. Okay, cool. Next thing. I picked up everybody's questions, right? Like nobody's making sure. Let's do another one. One moment. That'll work. Okay, so we've done an example of x approaching infinity. We've done an example of x approaching 0. Tristan said, well, what happens if x is approaching a number? Here's x approaching a number. And just for good measure, the AP test writer, these are all old AP problems. The AP test writer says, hey, students are getting pretty good with numbers. Let's mess it up. Let's throw in the alphabet. So here we go. Limit as x approaches a. So I check my little logical list, and it's not x approaching infinity, so I'm right here, factor. And I have a little dumb way of remembering this. If you forget to factor 2f's, failure is in your future. Seriously. If you're solving a limit problem, you forget to factor, failure is in your future. So, okay. I told you it was dumb. All right. Here we go. So this is equal to factor, we've got to use the Mr. Recty's hippo butt stuff. I always feel embarrassed when I say that. I have to look at the board so I don't turn red. And I noticed that, here's a great example of don't get on autopilot. Think as you go. Just relax and just think as you're working. I don't really need to factor the numerator, because when I factor the difference of squares in the denominator, it's going to look just like the numerator, and that's what I want. I want matching factors. So let's just leave the top alone. Mathematicians are like really, they're in love with syllables. Top, bottom, numerator, denominator. Another dumb joke. Okay, questions to that? Solid. Okay, so let's see, now we could write it like this. Okay, the step that I'm writing, if you want to skip this step, I'm okay with that. I just write it out to be perfectly clear. If you want to skip writing that step, that's okay. All right, so as x gets close to a, x does not equal a, x gets close to a. Whatever this is, it's exactly the same as this. So something divided by the same thing is 1. I have to consider that I could be a little more than a or a little less than a. But either way, when I square that value, it's going to be really close to a squared. A squared added to a squared will give me 2a squareds. So when the input gets really close to a, the output is getting really close to 2a squared. Questions?
I'm a little confused. Can we look at that last part one more
Huh?
time?
I'll probably try to get you to talk, and then it will usually sink in better. So when x is close to a, what happens to this, Maddie?
Doesn't it just divide to equal 0?
Oh, good comment. So let's see.
Equal 1, sorry?
Yeah, 1. So you're good there.
Yeah,
No
sorry,
worries.
I'm kind of spacey today.
No, you're not. You're fine. So this is 1. Fair?
Yeah.
Awesome. So I plug in, I need to replace x.
Oh, okay, that makes sense.
Oh, no worries. Because the whole idea is that this is the formula. Let me just finish because you're asking a very commonly asked question. This is how we find the output, by plugging in the input, right?
Yeah.
And all we've done is rewritten this in a way that's a little friendlier.
Yeah.
So now when we plug in, remember, you're not just plugging in, you're not plugging in a at all. You're plugging in like a plus and a minus.
Yeah.
But either way, when we square those values, they're close to a squared, and then now we have 2 of them.
Okay, that makes sense. Thank
Perfect.
you so much.
2 points. Anybody else? Awesome. Half the room is thanking you for asking the question because they had a similar blank look. So you're awesome. So I'm serious. Half the room's like, oh, I feel so much better now. So you just can't see them because you're not looking at them. So we good here? Perfect. We need to do this. We need to make sure we are clear as to what is the value of f of a. So raise your hand if you know what I'm supposed to write here. Extra credit. So what do I write here for f of a? So now we're not plugging in close to a. We are plugging in exactly a. So hands up. Get a few more people. Just plug in a. Just mentally work out what you get. Plug in a. So you get Drew.
1 over 2a squared.
So how many agree with Drew? Raise your hand. So we all get 2 points because the wrong answer is as good as the right one, and that one's definitely wrong. So as you know why, okay? So who has a different answer? Let's go Weston.
I got 0.
Tell me why.
Because I put a in for on the top for x, and a squared minus a squared equals 0.
Keep going.
So it doesn't matter what's on the bottom if it's 0 on the top.
Oh, gotcha. I'll give you 4 for that one. The answer, Weston, the reason I'm giving you 4 is because the answer you gave is wrong. It's okay.
Okay.
That's okay. But the way you said it was really, no, really, like you said something that I can tell exactly what's mixed up in your head. So it's a perfect example of having a wrong answer is fine, as long as we figure out why. Here's what you got backwards. The top is definitely 0, but so is the bottom. And anytime you have 0 divided by 0,
Oh, it's fine.
yeah, we don't know what that is.
Yeah.
No worries, that makes sense. What you mixed up, I'm pretty sure, is the opposite.
Yeah.
Like, if the bottom is 0, we don't care what the top is. That's undefined. And if the top is 0, but the bottom is some number, we don't care what the number is. That's just 0. So no, outstanding comment.
Okay.
Questions? Please.
Why isn't 0 over 0 just 1?
I don't know. I'm really serious. I don't know. I don't really know the answer. I have to go look it up. Outstanding. 2 points. So this is undefined. Please raise your hand if you knew it was undefined before we revealed that. Nicely done. Question. That's important. Hey, everybody. Like, you have to know this. You have to understand that when we found the two-sided limit, when we put in something close to A, we get a value. But when we put in exactly, we don't get a value. That's a removable discontinuity. You need to remember that. Removable, right here. The two-sided limit is not the same as the value of the function. Please.
Oh, okay, sorry. So
Really?
like going back to like when you got the answer for that one that you just did, you know how you plugged in A to the X? Did you just do that because it was like A was like a variable? So if we have like all these problems have X approaches like 0, X approaches, infinity, or X approaches a variable, right?
Oh.
Like why did you plug in A there, but like we never plugged in the 0 in the 0 one, we never plugged in the infinity on the infinity one? Like it's just because it's a variable one?
Outstanding question. 2 points. So in the case here where n was approaching infinity, you can't really plug in infinity because infinity isn't a number. Infinity represents the idea that n can get bigger and bigger and bigger. And so we did do that. Like we said, hey, right here, actually right from the beginning, if n's going to just keep getting larger and larger and larger, what's going to happen? Well, this won't change at all. It's just whatever it is. But these two, something interesting happens. This starts to dominate. It becomes so much larger than this that we can kind of neglect it. So we are really thinking of plugging in large values for n. Is that okay so far?
Yeah.
Stay with me. This one here, no, where'd it go? Hold on, I'll find it. Patience. There we go. No. Patience, more patience. That's it. When x was approaching 0, we really did plug in 0. Except that, again, reminder, it's not really 0 that we're plugging in. When we're finding the limit, we're plugging in close to 0, like a little more and a little less. But something different happened. When this is really close to 0, and these two get added together, this becomes negligible. And you get really, really close to -1. Because finding a limit means when the input is getting very, very close to something, what's the output getting close to? So we're still putting it in. And then to find f of 0, we just plugged in 0 right away. The difference was this function's continuous at x equals 0, so those two match. Whereas the one over here, come on, they don't match. So it's a removable discontinuity. But I don't know if that answered your question.
Yeah, well, I guess I'm just saying is like on the other ones, after you did the first step to simplify it and then the second step to kind of get it where they can equal 1, it kind of gave us like an answer 1, or give us an answer, negative infinity when you did it. But on this one, like the thing that you had left over was x squared plus a squared, so it's like not done yet. So then you have like so I'm saying like on homework when we have like these questions that have like x approaches a, if we get to the end and there's like still an x and an a in it, like I guess I'm saying, do you just plug it in to like finish it out?
Yes, no, that's well said. 2 more points. Just remember, you're not plugging in a, you're plugging in close.
Plugging in close. Okay.
Yeah, no, that's perfect. That's
Yeah.
very good.
Because we could have canceled just to a like that, you know what I mean? But just for this problem, it didn't. So we had to.
Well said. No, that's very well said. Some of the others, like it came to a point where like there was nothing left to do. So it's well said. It's very good. Please.
So I get like everything except for the as x approaches infinity. Can we do like
Another one of those? Sure. So everyone, let's move this out of the way. Write that one on your paper, please. Go. Sorry, it's a little blurry. Do this one. Go. Stop me if something pops in your head. You're like, wait a minute, I don't understand. So. Yes, because as you compare these that add, this is down. Compare these four that are adding, this is down. This is what Brennan was saying, I believe. Brennan, correct me if I'm mistaken, but I think you and I are thinking alike now. I was following what you're thinking. I just was not picking it up. That's my fault, not yours. That, like on this particular case, we get to here, and because these are equivalent, yeah, we are thinking of a large number being plugged in, but it's super easy.
Did you already get your answers?
Yeah, it's like, oh, that's just 1. So you're like, oh, it doesn't matter how large x becomes, this will become 1. 1 multiplied by 1/4 clearly indicates that when the input value is allowed to grow forever, the output's going to get very close to 1/4. So this is a case of where we do have a horizontal asymptote at y equal 1/4. Is that what you meant, kind of? Perfect. 2 more points. Allison, did that help?
Yeah.
You're good. Keep looking. I'm just checking what problems we've done so far else. You're okay. No worries. Take a look at this one for a second. Did I talk about this one in this class or this last period? So last period. So look at this for a moment. The question is the limit as x approaches infinity of e to the x divided by x squared. Same logic, different problem. There's nothing to neglect because you don't have anything being added. But you still can say, okay, wait a minute. As x approaches infinity, the top's going to get bigger. But so is the bottom. But because the top grows so much faster than the bottom, you get a situation where it's like, I don't know, 1 this big divided by this big. And then as x gets bigger, that just gets worse. Think of it this way for a second. You plug in a certain x value. In fact, I don't know, I guess we could just put it on the calculator to show you the pattern, but it's just going to grow bigger and bigger. So the end result is the y-coordinate is going to approach infinity as well. We want to talk more about this idea. Talk to me.
So I'm just like, kind of a generalization. If the exponents are different, then either the top or the bottom, no, like it's going to approach infinity or negative infinity. Is that?
Oh, not quite. So what happens, Cass, this is what you're thinking. If the top grows faster than the, like if they both grow, but the top grows faster than the bottom, or even if the top grows and the bottom is just a constant, then the value will head towards infinity. Whether it's positive or negative infinity simply depends on whether there's an extra sign out here, positive or negative. If this occurs, the limit as x approaches infinity, and we flip this thing the other way, now what happens is the top grows, so does the bottom, but the bottom grows so much faster that the whole thing is actually headed towards 0. Is that your question?
Yeah.
2 point. Anybody else? Please.
Can we, so on this one, on the like where x equals negative infinity, the example we did, that I did not do that.
Let me find it. Somehow I'm not finding it.
It's the limit of 3x, so 3x to the fifth plus 2x over 5.
Oh, this one.
Oh, yeah.
Gotcha. Oh, I got you. This one that I just wrote down by hand, that I made up.
Yeah.
Right. So this is more like what Cass was saying. So you're comfortable to hear
Yeah.
that we've just factored and separated. So now what happened, this is exactly what Cass is referring to. Okay, no matter how large x gets, this will stay 1. Good. So what I would have now, if I want to write one extra step just to make it a little easier to see, is this, Allison. So give me a second to rearrange. The magic of technology. That didn't work. Hold on. Stupid board. Stupider board. Okay. There we go. Okay. So if I add one more line, I say equals. Okay, blue, whatever. So this is equal limit as x approaches infinity of just negative 3 over 1 and x over 1. So if x gets really, 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 really big, this doesn't do anything. It just stays what it is. But this just gets bigger and bigger and bigger and bigger. So think of it as this way. X could be 1,000,000. Times negative 3 would be negative 3 million. X could be 1,000,000,000. Times negative 3 would be negative 3 billion. X grows some more to 1,000,000,000,000. Negative 3 trillion. So as x gets bigger and bigger, y is just getting more negative.
Okay.
So the negative only applied because we had this extra negative multiplier. Otherwise, this gets big, that gets big. Did that help?
Yeah.
Okay, 2 more. Awesome. Next thing. And that one. And that one. Let's do this one right here. Right here, write that down. So the limit as x approaches negative 4. The numerator is x squared minus 2x minus 24. The denominator is x squared minus 16. X is not approaching infinity, so I can't make easy comparisons between adding terms. So I don't forget to factor, and I will fail in the future. So, let's see, limit x approaches negative 4. Hippo butt.
I understand.
Mr. Recty's terminology, not mine. It does seem to kind of stick in your head. So this is x, x, subtract 4 plus 4. This is x, 6 and 4, negative, positive. Questions? You do have to be good at factoring. Not hard factoring. You have to be good at basic factoring for this class. It comes up all the time, just repeatedly, all year long. So, cool. All right. Now I can rewrite it like this. This is back to Brennan's comment and also Tristan's. 2 more points for each of them. I treat questions kind of like songs on the radio. Every time a song is played on the radio by Taylor Swift, she gets money for the song being played on the radio. So every time I reference Tristan or Brennan's comment, they get more points, so 2 more each. Getting royalties for questions. X is not going to equal negative 4, but x will become very close to negative 4. If that happens, this will become 1. In fact, this is equal to 1, except for one value of x. So raise your hand if you know the value of x which causes this to stop equaling 1. Like this is equal to 1 always. Any value you want. Plug in any value you want in for x, and it's going to equal 1. Except for one special value that you have to be careful with. Show me your hands. What's the one bad value that we plug it? There we go. What's the one bad value if we plug it in, Camry? Negative 4. How many knew it? 2 points. But when we're doing a limit, we're not plugging in negative 4, so no worries. We're just plugging in close. So this becomes 1, and now this is Brennan's comment. Now you've got to think through what happens when you plug in a value that's close to negative 4 into what remains. Well, it wouldn't matter if I were a little more or a little less than negative 4. Subtracting 6 is going to be close to negative 10. Doesn't matter if I'm a little more or a little less than negative 4. Bottom's going to be close to negative 8. So that means when the input is close to negative 4, the output's really close to negative 10 divided by negative 8. Somebody's phone is talking to me. I assume that's a phone. What is that? It's mine. That's weird. Oh, Maya found it. Silence the beast.
Sounds like that.
So maybe it's your metronome or something. No worries. Happens to all of us. Figured out?
Yeah.
Okay, all good. So this reduces to 5/4. So when the input is close to negative 4, the output is close to 5/4.
Do they want us to reduce it?
Don't have to. Multiple choice, you'll have to, because they'll have the answer like this. Written question, this is fine. So my answers in the back will look like this, Mikkel.
Okay.
So we should reduce them on the right?
What I would do is reduce it until you can get the answer on the back.
Okay.
But don't stress about the reducing. Raise your hand, please. Who knows what goes here? Like, we've got to keep track of the difference between finding a limit versus finding the value of the function. Who knows what goes here? I want to see all hands. If you're not sure, yes. Because participating is better than just passively watching. So what goes here? Isaac, sorry, get your name.
0 or undefined.
Nicely done. When you plug in exactly 4, sorry, negative 4, you get undefined. How many knew it? Show me your hands. 2 more. Everybody gets 2 for trying on that one. So, good question. You will not see it once you see the answer. Because if you plug in exactly negative 4, remember, we only got to here because we were getting close to negative 4. If you plug in exactly negative 4, this becomes undefined.
So this one be removable?
Nicely done. 3 for Danny. When the two-sided limit does not match the value of the function, removable discontinuity. Perfect. Anybody else? Awesome. Do this one, please. I'll just walk the room, make sure you can get it. Right here. Go. Stop me if you have a question. Questions on the red? Please.
I was just thinking, would it, if X approaches like anything besides infinity, there's not ever more than last point.
Oh, well said, yes. Well, it doesn't mean there isn't one. It means you're not finding it. Yeah. When you're checking the limit as x approaches infinity, whatever you get as a result, that's the horizontal asymptote. So if we're not checking the limit as x approaches infinity, we just haven't kind of investigated that. Perfect.
Is 0 over 0 undefined?
Yes. So two cases there, Rachel, to remember. 0 divided by 0 or number divided by 0,
Okay.
both undefined. Perfect. Okay, eyes on me, real quick. Okay, the homework tonight is to finish the buff, except don't do problem number 42. Toss that one off. I don't want you to worry about that one. So do the rest of the buff packet, skipping 42.
Mr. Smith, so do you want us to put that horizontal asymptote on all the easy ones, but put the F?
Yeah, it doesn't say that, but it really will help if you do comment. And one last thing, listen close. Hey, silence real quick. They have said this, but I'm going to say it again. Don't use the answers to figure out the problem. Use the answers to verify that you're using the correct logic. Otherwise you'll invent math that doesn't exist. It's really bad. I'll tell you a funny story about that if you remind me.
Good morning. I need the following people to come down to the main
Bring your
office.
outfit.
Thank you.
Maya,
Well done.
Tyler,
So,
Emily,
how I started
Mason,
saying
Wade, Jonathan, Kicken, Gabby and Maddie Richards, Sam Clark, Pearson Smith, and Len. This was the main office.
I did it wrong.
Thank you, Mr. Smith.
You got it? Oh, you're still right. You're right.
Thank you.
You're welcome. limit
Like picture day and occasionally when this happens.
Don't
get used to it.
Oh, I don't try the last day.
Last day it's like, I'm going home.
Yeah.
I just.
It's not right. You're wondering why.
Yeah.
Got it.
But like you did that on the, except I was like,
Gotcha. So you're misremembering what I did on the other one. We'll look here in a second. Are you done, Allison?
Yeah.
So, okay, you're doing, what you are doing now is perfect. You're asking your question instead of assuming something. Too many people just assume. The reason this is incorrect, and let's just keep talking until this feels good to you. You can only break up something like this into this times this times this if what you started with was factored. So this isn't factored because it's really a term plus a term divided by a term plus a term. When I broke it up, I think the one you're remembering, we'll find it. Hold on. Just a second. Well, let's look at some examples. So right here, I can't break it apart. But once I identify that because n is approaching infinity, this is negligible, and I get this simpler limit problem, now I have factor times factor, and so I can break it apart. Because if I multiply it back together, 4 times n squared is 4n squared, and that's also n squared. Like here, if I multiply this back together, so what we're thinking is this should equal, and it doesn't because this times this times this is negative 2x.
yeah.
Did that answer your question?
Yeah.
Okay, no worries. People do that all the time. No worries.
Okay.
Good?
Yep.
Okay, good job, Kat.
I'm gonna be gone next time, so can I come in at